Metric units are typically easier to convert between because the metric system is base 10, just like our number system. The way we do the conversion is still using the same thing with the US standard units called unity fractions. Let's kind of look at the metric system really quick and how it does the conversions between the base unit being either meters, which is a length measurement, grams being a weight measurement, liters being a volume measurement, these types of things. So if we look at the base unit, that would be meters, grams, liters, those kind of things. The metric system has prefixes to designate if it's smaller or larger than the base unit. The first one, going smaller, is called the deca. So it'd be the deca prefix, decimeter, decigram, deciliter. This really isn't used in practice at all. It'd be, I believe, dm or dg or dl. But it's not really used in practice. It is 10 times smaller than the base unit. In other words, if we have 10 decimeters, if we have 10 of them, then we have one meter. Or 10 decigrams, we have 1 gram. Okay, looking at the next one, we have a centa. This is used because a centimeter is closely related to an inch. It is 2.54 approximately. And this, of course, is just cm. If we have 100 of these, we have 1 meter. Millimeter is used very commonly. This is 1,000 of these makes one meter. It's just going to be mm. And then after that, we don't really take steps of 10. So we wouldn't have 10,000 or 100,000. We actually take steps of 3. So the next one's going to be a micrometer. That's going to be this long M here, micro, MICRO. If we have 1 million of these, we have 1 meter. Then you get smaller, like nanometer is 1 billion equals 1 meter. Picometer, femtometer, these get smaller and smaller to where you get closer and closer to the size of like the diameter of an atom, things like that. Now, that's smaller units. Now we can go bigger units. The first one would be a decameter. I'm not sure what the unit is for that, but I believe the prefix is deca, like that. Or no, DECA. This isn't used pretty much at all as far as I know. And this would be just 10 times as big. So if we had 0.01 of that, we'd have 1 meter. Because if we had 1 decameter, we would have 10 of the base unit. We'd have a much larger amount. So 0.1 of the decameter is the same as 1 meter. It's much, much larger. A hectometer is the next one. It's 100 times as big as a base unit. So we need a smaller unit to represent 1 meter. Or of course, 1 gram or 1 liter. It's all the same thing. What is used commonly is the kilo. The kilometer or kilometer. This is 1,000 times as big as the meter. So 0.001 is 1 meter. Or in other words, 1 meter equals 1,000. Oops, let me go the other way. 1,000 meters equals 1 kilometer or kilometer. And then, of course, you take the jump. These ones you should recognize probably more than the jump here. 3 times as big as the kilometer is going to be the mega. The next jump is the giga. The next jump would be the tera. And those you should be familiar with computation. Kilobytes, megabytes, gigabytes, terabytes, because the base unit would be byte. Then 1,000 bytes equals 1 kilobyte. 1,000 kilobytes or 1 million bytes equals 1 megabyte. The capital M, megabyte. And so on and so forth. So the metric system is base 10, just like our number system, and the way we use it is the prefixes. That's what tells us how big and small it is. Okay, to actually do the conversions, there are conversions on this table. The lower half down here is kind of the metric system, and for all of them. But you can also use just the idea of the prefixes to solve these problems. So for instance, 2 liters, a liter, 1 liter is 1,000 times as big as a milliliter. So that means there's 1,000 milliliters in 1 liter. So we get 2,000 milliliters. Now, a kiloliter, that's not really used much. Maybe it is in certain sciences, but not really everyday language. But we can still do it. Like, it's just a prefix that we can use in the metric system. So 1 kiloliter is 1,000 times as big as a liter. Kilo is a bigger unit of measurement. We have 24,000 liters. All right, 420 grams. A kilogram is 1,000 times as big as a gram. Kilo is much bigger, right? And then we have 420 divided by 1,000. This is going to be in kilograms because grams will cancel here. And when you divide by a base 10, you just take a decimal and count how many zeros. 1, 2, 3 zeros in the bottom. 1, 2, 3 spaces. 0.42 kilograms. Whenever you divide by a power of 10, or like 10, 100, 1,000, 1,000, 10,000, 1 million, 1 trillion, just count how many zeros are in the denominator and move the decimal point that many spaces. That's because our number system is base 10. All right, 1.5 grams. 1 gram is 1,000 milligrams. Of course, grams cancel. And we get 1,500 milligrams. 80 meters. Meters on bottom and kilometers on top. 1 kilometer is 1,000 meters. We have 80 over 1,000. 1, 2, 3 zeros. Decimal points right there. 1, 2, 3 spaces. Add a 0 where there's a spot that was skipped. And so we have 0.08 kilometers. 3,500 millimeters. So millimeters on bottom, meters on top. 1 meter is 1,000 millimeters. You can see those cancel. Now we have 3,500 over 1,000. 1, 2, 3 zeros. So we go 1, 2, 3 spaces. 3.5 meters. This one's slightly different. We have 400 centimeters. Now you can do this 2 ways. You can actually convert to the meters and go back to millimeters if you're confused in how centa and milli compare. Just to show you that, if we have centimeter on bottom, meter, 1 meter is 100 centimeters. Now this is different because a centa is only 100 times as small as a meter. Now we can convert between 1 meter and 1,000 millimeters. Now you see on top we have, well, you can cancel these 2 zeros with 2 of those zeros. We get 400 times 10 is 4,000. And this is over 1, so it's just going to be 4,000. Just do the multiplication out and you'll get the same number. It's going to be millimeters. So that we converted, that was a long step process. You don't have to do that. If I go back up to the unit kind of baseline measurement here, this is times 10. There's 10 decimeters in a meter. There's 100 centimeters in a meter. There's 1,000 millimeters in a meter. Between each step, though, it's only 10 times, 10 time difference. So a centimeter is 10 times as big as a millimeter. A decimeter is 10 times as big as a centimeter. A meter is 10 times as big as a decimeter. Decameter is 10 times as big as a meter, and so on and so forth. And of course, you can also make steps differently. A decimeter is 100 times as big as a millimeter. Okay, so what we could have done here is said 400 centimeters. 1 centimeter is 10 times as big as a millimeter, and that will give you 4,000 millimeters. If you're not sure of that, though, you can always convert back to meters and then go forward to millimeters. That's fine. These multiplication that we're doing here isn't very hard because all we're multiplying by is powers of 10, which just move the decimal point because our number system is base 10. Okay, 3.8 meters. 1 meter is 100 centimeters. Meters cancel, and we get 380 centimeters. 10,000 milliliters. 1 liter is 1,000 milliliters. Those cancel, and we get 1, 2, 3, 1, 2, 3, 10 liters. Okay, 0.002 kilograms. For this one, we can go, I'm pretty sure that's supposed to be a lowercase m. Yep, that was my bad, lowercase m there. So we're going from kilograms to milligrams. So if you're not sure of the direct conversion, which is going to be 1 million times as small, so there's 1 million milligrams in a kilogram, you can go to the baseline measurement, which is grams. So 1 kilogram is 1,000 grams. And then 1 gram is 1,000 milligrams. Now you see the units cancel nicely, and we get just milligrams. And really all we have here is 1, 2, 3, 1, 2, 3. So we get 1, 2, 3, 4, 5, 6. So we get 2,000 milligrams. You can, of course, just put this in your calculator, and you'll get 2,000 milligrams. Okay, 246 kilometers per 1 hour in meters per minute. So 1 kilometer is 1,000 meters. 1 hour is 60 minutes. Those cancel. Those cancel. And we get meters on top, minutes on bottom. So we've gotten the correct units. This is going to be meters per minute, which gives us 4,100 meters per minute. Okay, we have a contaminant in the reservoir that's measured at 0.15 milligrams per liter. How would this be expressed in parts per billion? Parts per billion, also parts per million, is a common way of measuring contaminants or kind of distribution in like gases, because like especially with gas, there's such a small amount in the gas. They use a small unit of measurement, parts per billion or parts per million, to get it so that the units are actually usable rather than like 0.0000563. It'd be just like 5.63. Much easier to work with. Okay, we need to get this in parts per billion. And what we know here is that 1 microgram, this is the symbol, it's mu from the Greek. It stands for micro in the metric system, which is 1,000,000 times as small as the base unit of grams. 1 microgram per liter equals 1 parts per billion. So we need to change 0.15 milligrams per liter to micrograms per liter, and then we can convert directly into parts per billion. So 0.15 milligrams per 1 liter. A microgram. So if you're not sure, you can convert back to the baseline measurement, which would be just gram. So gram, milligram. In 1 gram, there's 1,000 milligrams. And in 1 gram, there's 1,000,000 micrograms. Okay. Then we can convert this to, this is going to be a little bit odd. I'm going to write this, but I'll show you why I'm writing it this way. 1 part per billion over 1 microgram per liter. Okay. What I have here is the milligrams cancel, the grams cancel, and now this microgram per liter, this thing right here, what this ends up doing is it's a division by a fraction, which means we actually instead multiply by the reciprocal. And I'm just writing it this way so that you see that micrograms cancel and liters as well cancel. And what we're left with is parts per billion, which is what we want. Really, at this, once you get micrograms per liter, 1 microgram per liter is 1 parts per billion. So you can just change the units because they're directly the same thing. But I wanted to show you that in the unity fraction. Okay, now we have 0.15 times 1 times 1,000,000 times 1 over 1 times 1,000 times 1 times 1. 3 of those cancel with 3 of those. And we get 1, 2, 3. So we get 150 parts per billion at the very end of it. All right, Taipei 101 in Taipei, Taiwan is 509 meters tall. The fastest elevators at 60.48 kilometers per hour. How many seconds, so we want seconds, would it take for an elevator to rise the entire height of the building nonstop? So we're converting from the height of the tower, 509 meters, into seconds, and we're using the speed at which the elevator goes to do that conversion. So we have 509 meters. The problem here is that the green here, right, this is in kilometers. So we need to change this first to kilometers, which is going to be kilometer on top, meter on bottom, so they cancel. 1 kilometer is 1,000 meters. Now we can multiply by the conversion ratio, and this is 60.48 kilometers per 1 hour. That's the same thing as, so let me write it like this. That's what that means. It's called a unit fraction, meaning it has a 1 in the denominator. Now we have to flip that though, because kilometer is on top. We want kilometer to be on bottom for 1 hour. Now we see that we have a time here. Meters cancel, kilometers cancel, and we have just hours. We want, however, how many seconds, so we need to convert this time into seconds. 1 hour is 60 minutes, and 1 minute is 60 seconds. And there we go. We have the correct unit. We have seconds at the very end there. Now all we have to do is do the multiplication. On top we have 509 times 60 times 60. On bottom we have 1000 times 60.48. And I'm getting 30. It doesn't say where to round it, so I'm going to round it to 2 decimal places. Round to here. That is 5 or greater, so I need to add 1, which means that this thing gets added to 1 because 9 plus 1 is 10. You have 30.30 seconds. That's how long it takes for the elevator to go all the way from the bottom all the way to the top. That's very fast. All right, here's the density of zinc. What is the density expressed in kilograms per cubic meter? So we have 7.13 grams per 1 cubic meter. And we want kilograms, so kilograms on top, grams on bottom. 1 kilogram is 1,000 grams. And we want kilograms per cubic meter, and we have the hint here. It says 1 cubic meter is 1 million cubic centimeters. So a cubic centimeter to a cubic meter is 1 million to 1. We need to round to the nearest whole number when we do this. Those 3 cancel with those 3, and we have just 7,130. Let me make sure my units are correct. Grams cancel. Centimeters cubed cancel. We have kilograms per meter cubed, which is what we want. And that's already rounded to the nearest whole number. So that's the answer. Okay, here we have a nurse that needs to infuse intravenously a solution at 15 drops per minute. If the drop factor is 20 drops per milliliter, how many hours and minutes will it take to administer the solution? So what we have is a 750 milliliter solution, and we're trying to convert this into a time. So without kind of like planning out, let's just write down what we know. We know we have 750 milliliters, and now we need to multiply it by something, and at the very end we need to have a time. There should be a time. Okay, so let's look at what's given to us. So we've used this already. This says 15 drops per minute. The problem, however, that gives us a time, but that gives us drops, and we don't have anything in drops here, right? There's nothing written here as drops. So it doesn't help us quite yet. The next statement, however, if the drop factor is 20 drops per milliliter, that we can use. 20 drops per milliliter. That's actually what we want per 1 milliliter. We want 1 milliliter on the bottom, 20 drops on top. So now we've converted between milliliters and drops. And now we can use the 15 drops per minute. So 15 drops per minute. We want drops to be on bottom. So we're gonna have 15 drops on bottom per 1 minute on top. And you see that the drops cancel. And now we're left with a unit of time, which is minutes. So we have the unit that we want in the end. All we have to do then is multiply everything out. On top we have 750 times 20. On bottom we just have 15. And so I get 1,000 minutes, which of course you can convert this into hours by dividing by 60, giving you 16.67 hours.